and then Mr. Pangubatan Melvin, and then Ms. Arsaba Joanna Jane. Table of contents. First, the volume estimation, methods of estimating tree volume, biomass estimation, allometric model for biomass estimation, carbon content estimation, sequestration capacity of trees, growth, yield, and economic rotations of plantation species, harvesting and transport, variety of forest ecosystem, and lastly, the glossary of terms. Estimation of volume, biomass, and carbon content of trees. So, forest plantation requires estimation of volume, biomass, and carbon content, which are important information for growth and yield forecasting. Of course, it is a plantation management, so there is necessary for us to predict the actual harvesting. So, growth and yield information serve as the basis for determining the stand performance and the relative productivity of the land. Of course, the quality of the timber matters. Magmatter ang quality sa timber kung ang land is productivity pa siya or dili. So, it is indispensable for updating inventories information, management planning, evaluating silvicultural options, scheduling harvest, and carbon accounting. So these three methods that are applied in the plantation management is very important kay there is an mag-inventory man, so
volume estimation. Volume is the most widely used measures of the amount of wood present in an individual tree, which is usually measured in cubic meters, specific to intended commercial products such as pulpwood and saw timber or solid wood. Individual tree diameter and height are essential measurements required for estimating wood volume. Since volume estimations deals with measurements of forest product, when calculating the volume, the factors such as age, diameter or height, wood density, crown width, and so on must be taken into account, as must the given that is intended for commercial production. So the purpose of the volume is that if ang tree ay to be cut to provide lumber, an estimate of volume is needed to determine what size and how many trees to be cut. Predictions of wood cubic volume may be referred to a total tree including branches or stem volume above a certain merchantable limit. Tree volume predictions equations have been developed for important forest tree species such as agoho, bagras, benguet, pine, giant ipil-ipil, gubas, kaatoan, bangkal, mahogany, malapapaya, mangyum, mulave, rintri, ridlawaan, and yamani. Merchantable height may be defined as the distance from the base of the tree to the first occurrence of either. So the highest point on the main stem, where the stem diameter is not less than some specified volume. The lowest point on the main stem above that stump, where utilizations of the stem is limited by branching of other defect. So merchantable height is used to predict conventional merchantable woody material. So the height above the ground or above the stump height, which is sellable for a particular product, and it's depends sa product you are making from the tree. For example, the pulpwood, ang height measurement is 8 foot length, or called half logs, or that is the standard of the pulpwood. So na yung mga standard depende sa product. So there are two broad categories, the direct methods and indirect methods. So the direct methods includes fluid displacement, graphic methods, standard, sectional method, taper, line. Indirect methods include volume tables, volume equations, integrated tapers equation, variance reductions methods.
So what is biomass estimation? So biomass is a total of a mass living expressed as oven dry tons per unit area. It's estimated by may be restricted to the above ground portion of a trees of the trees components such as tree trunks, branches, or foliage. Therefore, biomass is regularly measured to survey the ecological status put away within the vegetations, which can demonstrate the potential efficiency of the location. So what is biomass estimation, guys? So dapat diri apil ang biomass calculations. So the biomass calculations, it has a net biomass net increase the biomass or the gross, decrease the biomass or gross also. So this kind of calculations is I didn't put it in our PowerPoint, but by subtracting and decreasing the biomass from this gross, increase the biomass and the net change in overall in biomass for specified time period that's to be determined. So biomass is when we can measure the biomass of each tropic level by multiplying the dry mass of a sample from that level. So about the total and also the total population in that level. Okay, next. The biomass informations on the whole tree and component parts are important to plantation managers, tree growers, and other end users for various purposes. The total biomass is found by summing the dry mass or a biomass of all individuals in a given land area, and then reported by naming the area per lot, biomass per lot, ecosystem, biome, or classroom. So let's proceed. The allometric model of the biomass estimation. So what is allometric biomass estimation? So allometric equations provide the biomass estimates from the tree measurements such as the diameter and the breast height or the DBH. So meaning sa DBH is diameter breast height. Height and or wood density. These equations captures the scaling relationship between the tree from a function to predict a total component. For example, is nadiri ang branch, needle, bark, bole, or root. So that is okay. Let's proceed sa ERDB. So sa man yun ERDB, guys. So ang ERDB is based on a study the average of the total biomass, tree biomass, and the percentage of the total dry weight of the 7 forestry species are as follows. So naadiri ang species kaning Vargas, Falcata, Giant Ipil-Ipil, Mahogany, Malapapaya, Mangyum, and Yemeni. So ginakuha po nato ang ilaang tree biomass or ilang kilo o ilaang percentage of the total dry weight. Okay. So sa Vargas, yung fresh is kilogram is 116.90 ug yung oven dry na kilo is 50.30. Okay. Na lesson ang yang kakon kay oven dry naman. So ang Falcata is 232.41. So pag oven dry is 124.78. Then sa Giant Ipil-Ipil is 137.44. So yung oven dry kilogram is 76.90. Then sa Mahogany is 91.01. Then sa yung oven dry kilogram is 48.06. Then sa Malapapaya is 65.60. Then sa oven dry kilogram niya is 26.50. Then sa Mangyum is 193.02. Then sa oven dry kilogram is Then sa Yemeni is 135.16. Then yung kilogram sa oven dry is na less than sad, 57.23. So, ato na punta silang bowl. Then ang bowl sa Vargas is 49, sa Valcarta is 46, sa Giant Ipil is 71, sa Mahogany is 78, 62, Malapapaya is 78, Mangyum is 57, Yemeni is 69. So sa ilang leaves is ang Vargas is 6, Valcarta 5, Giant Ipil 4, Mahogany is 9, Malapapaya is 6, Mangyum 8, and Yamani leaves is 6. So silang branches, isang Vargas, it has 45, Valcarta has 49, Giant Ipil has 25, Mahogany has 29, Malapapaya has 16, Mangyum has 35, and Yamani has 25 branches.
Carbon content estimation. Trees take up carbon dioxide from the atmosphere and store the carbon in their biomass. Tree trunks, branches, foliage, and roots through photosynthesis. This means that the higher the biomass accumulation, the greater the capacity to sequester carbon. Ang carbon dioxide, isa na siya sa kinahanglan kay sa tree para ang isa ka tree makaproduce og food. O gitawag na to siya nga process o photosynthesis. Kung mas higher ang biomass accumulation sa tree, mas greater yung capacity to sequester carbon. Sequestration capacity of trees. The sequestration capacity of trees may vary in terms of species, age, and location. Rapidly growing trees absorb a large amount of carbon dioxide. Mature trees grow less rapidly and those have lower intake of carbon dioxide. When trees reach their overmature state, the rate of sequestration tends to be negative because biomass material is breaking down faster than it's accumulating. So the sequestration capacity of tree magdepende jud na siya sa species, age, o location. Ang kanang mga paspas nga motubo nga tree kay mas dako ilang i-absorb na amount sa carbon dioxide, o kanang mga mature na tree mas hinay na po na sila mo absorb og carbon dioxide. How to calculate carbon dioxide sequestration? First, determine the total grain weight of the tree. The grain weight is the weight of the tree when it is alive. First, you have to calculate the grain weight of the above ground weight as follows. Above ground, 0.25 diameter squared height and 0.15 diameter squared height. So kaning 0.25 diameter squared height, mo ni siya gamiton nga formula if ang imong diameter is 11 inches below, o ang 0.15 imong gamiton kung ang imong diameter is 11 inches above. So the diameter should be in inches ug ang height should be in feet. The root system weight is above 20% of the ground weight. Therefore, to determine the total weight of the tree, multiply the above ground weight by 1.2 total green weight. So, para makuha na to ang green weight, total na to ang above ground sa 1.2. Step 2. Determine the dry weight of the tree. The average tree is 72.5 dry matter and 27.5% moisture. Therefore, to determine the dry weight of the tree, multiply the total grain weight of the tree by 72.5. Para makuha na to ang dry weight, i-multiply na to ang 0.725 sa green weight. Mao na ang dry weight niya. Step 3. Determine the weight of the carbon in the tree. The average carbon content is generally 50% of the tree's dry weight total volume. Therefore, in determining the weight of carbon in trees, multiply the dry weight of the tree by 50%. So, i-multiply na to ang dry weight sa 0.5. O, muna na ang carbon. Last step, step 4. To determine the weight of carbon dioxide sequestered in a tree, carbon dioxide has 1 molecule of carbon and 2 molecules of oxygen. The atomic weight of carbon is 12 and the atomic weight of oxygen is 16. The weight of carbon dioxide in trees is determined by the ratio of carbon dioxide to carbon is 44 divided by 12 equals 3.67. Therefore, to determine the weight of carbon dioxide sequestered in the tree, multiply the weight of carbon in the tree by 3.67. Para makuha ang carbon dioxide, i-multiply na to ang 3.67 sa carbon. Ingaton pag-solve o pagkuha sa pila ang carbon sequestered sa usa ka kahoy. Example, natay 10 years old tree with a height of 5 meter or 16.4 in feet and the diameter of 25 centimeter or 9.8 in inch. Sa ako pang ganina, ang height na to dapat naka-feet o ang ato ang diameter is naka-inch. Kung magkuha ta sa atong above ground, naka-pounds dyan na siya. So, since 11 below ato ang diameter, atong gamiton is 0.25. Diameter squared times height. So, sa pagkuha sa ato ang above ground is 0.25 times diameter squared, which is 9.8 squared, times 16.4, which is our height, is equal to 394 pounds. So, mao na to ang above ground. Sa pagkuha po sa ato ang total green weight is 1.2 times above ground, which is 394, is equals to 473 pounds. Mao na to ang total green weight. So, kung mga tanan mo, asa na nagkuha ang 1.2, given na siya. Sa pagkuha po sa dry weight, 0.725 times 473, which is our total green weight, is equals to 343 pounds. Mao na ato ang dry weight. Sa pagkuha po sa atong carbon is 0.5 times ato ang dry weight, which is 343, is equals to 171.5 pounds. Sa pagkuha po sa ato ang carbon dioxide, 3.67 times ato ang carbon, which is 171.5, is equals to 629 pounds. So, mao na ato ang carbon dioxide. So, therefore, the carbon dioxide sequestered in 10 years is 629 pounds. That's equals to 205 kilograms.
Growth, yield, and economic rotations of plantation species. Growth, yield, and economic rotations are essential in the management of plantations to help managers with forest planning and accurately predict wood content of forests from their plantations. Of course, plantations man, so na ay mga revenues or kanang income sa what type of wood ilang gi-apply for that plantations kay magmatter man ang income nila. And then it answers questions in forest management such as when to harvest or where to transport, what time or unsa nga what date, and how much to cut or pila ra ka buok or selective lang ang ilang ikat. And then independent variables used in growth and yield modeling for forest plantations, age sa wood or sa species, site quality, of course the land, and then the density or pila ang ma-produce nila nga tree. So according to Davis 1966 of American Forestry Society states that forest rotations is the period of years required to establish and grow timber crops to a specified condition of maturity. So the forest rotation simply means that after the timber is being harvested, so it needs na ang land i-relaxa dayon relax siya for another batch of species to be used in the plantation. So according to Davis 1966 of American Forestry Society states that forest rotations is the period of years required to establish and grow timber crops to a specified condition of maturity. So the forest rotation simply means that after the timber is being harvested, so it needs na ang land i-relax dayon relax siya for another batch of species to be used in the plantation.
My name is Joanna Jean Ersa Saba, and I'm going to report harvesting and transfer. The harvesting process consists in the mission to get the tree from the forest site to a wood processing mill. Forest harvesting refers to the cutting and delivering trees in a productive, safe, economic, and ecological process. It includes the conversion of trees into merchantable raw material according to specific industrial or individual requirements and needs. And it includes the cutting of trees, their conversions into logs, extractions, and long-distance transport to a consumer or processing plants. These are the important operations in plantation management. First, peeling. Peeling involves in cutting a standing tree and dropping it in the place you want it. So, ang peeling kay kanang pagputol sa wood or trees nga inyong gamitong timber. So, kuan ang pagkat ani kay depende ninyo kung asa ninyo i-place pag hagbong. So naani siya kanang marag PC nga inyong ginamiton pagbira para dito mo landing ang trees. Limbing or delimbing is the process of removing branches from a standing or fallen tree trunk. So ang dilimbing kay kaning pag kung siyang sanga-sanga pag remove, pwede siya gamiton sa kamot or kanang tool nga pampa-remove sa mga sanga-sanga. Debarking. Debarking is the process of removing bark from the wood stem. So ang kaning debarking kay kaning pag-remove sa iyang panit bitaw nga panit sa tree or wood. So kana backing is the process of removing the flower and leaves from the stalk, which can be done by hand or through the use of a backing machines. Chipping. Chipping is an overarching term that refers to the process of removing the hard or dry material like rock, concrete, and etc. from a surface. So while chipping, ang katunggahe nga bagay is dukdukon or bundakan og kanang bugat nga tool aron madugmok siya para ma-remove siya og para-remove siya sa tree or wood. Wood extraction. Wood extraction is the process of moving trees or logs from the cutting site to a landing or roadside where they will be processed in logs or consolidated into longer loads for transfer to the processing facility. So, ang wood extraction is kanang pagbutang sa mga tree or wood dito sa yang butanganan para pag-load sa truck. So, na siya ang wood extraction. Peeling. Peeling is the temporary storing the harvested crop in stack or piles. Ang peeling is kanang pag-pile sa mga wood or tree para dali ra siya pagbutang sa kuan truck. So, kailangan siya i-pile og kuan butang. Loading. Loading is kanang pagbutang sa mga wood or tree sa truck na maghatod sa mga wood or tree sa iyang final destination or wood mill. Wood or timber transport is the movement or wood or timber from one place to another. The wood or timber transport usually enables a link between a forest and mill, regardless of what type of timber or wood is to be transported. The appropriate commercial vehicles are used. Ang wood or timber transport na pamagi is pwede siya sa sa road, rail, or kanang sa train, ship, or waterway na pwede gamiton pang transport sa wood or timber product. Variety of forest ecosystem. From dry savanna to evergreen tropical rainforest, big differences exist in biodiversity, wood volume produced per area, soil, and climate. No matter what forest ecosystem is intended to be managed, they are all very sensitive and may be easily degraded or destroyed. So, bisan paglaylay sila pamaagi or pag-catch up sa pagdako sa tree ug pagproduce og wood tungod sa yuta and climate na ilang na andan, sin Japon tanan nadali